Morning. This next section in Unit 9, Interpreting Lines of Best Fit. We're going to change it to 9.4b. So in this second section, yesterday you learned how to calculate the line of best fit using the graphing calculator. Today we're going to now interpret this line of best fit and look at the different parts and decipher what they mean in regards to our context. So linear equations can be used to model and understand the relationship between two variables. Example number 1, the cost of a flight is related to the distance of the flight, can be modeled by this equation, y equals 0.0867x plus 32.1, where x is the distance in miles and y is the cost in dollars. So it is important to know what these variables represent. Now, if you'll notice, this equation that they give us should look familiar. It is written in slope-intercept form. So it's written in the y equals mx plus b, where m is our slope and b is the y-intercept. So on this first example, they want us to, on part A, explain what the slope of the line represents in this context. So first of all, find the slope, and it's the number in front of x, so 0.0867. So our slope would represent the additional cost for each mile. Because remember, our slope is always this rise over run. So the 0.0867 is our rise, which is the cost in dollars. So 0.0867. For each run, which is the x value, which is mile. Or for each additional mile. And we want to be as specific as we can when we are explaining what these values mean. So for part B, what does the y-intercept of this function represent? So remember, b, the y-intercept would be this last number here, this 32.1. And I'm going to have you write it as an ordered pair because I think that helps us in the explanation. So our y-intercept always has our x equal to 0. So our ordered pair is 0, 32.1. That helps us when we're explaining. When x is 0, or we could state our x is distance in miles, if we travel 0 miles, our cost would be 32.10. So the cost of $32.10 of a flight that travels 0 miles. And it doesn't matter whether you talk about the $32.10 first or the 0 miles first. You could have switched the order around. Which a lot of times the y-intercept will not make a lot of sense when we are looking at these real-life problems. Part C, what would be the cost of a flight that travels 1,250 miles? So for this problem here, we're going to use the equation that they gave us up at the top. And they're giving us the 1,250 miles, which is an x value, so we'll substitute in for x. So in this equation we have 0.0867 times x, which is 1,250, then plus 32.1. So if you get your calculator out and type that in, we are going to round to the nearest dollar, so our cost would be $140. Part D, how much would a 3,300 mile flight cost? So again, we're using this equation and substituting 3,300 in for our x value. And don't forget to add that 32.1, which is at the end of that equation. Type that in the calculator. Rounding to the nearest dollar, this flight would cost $318. And then for part E, what distance corresponds to a cost of this much? So this time they're giving us something different. They're giving us the cost, which is our y value. So if we look at our equation, instead of replacing in for x, we're going to replace in for y, the 180. So let's write out what we have. 180 equals 0.0867x plus 32.1. So here's our equation that we are now solving for x. So subtract 32.1 from both sides of this equation. So we have 147.9 is equal to 0.0867x. Divide by this 0.0867 on both sides. And we're going to round to the nearest mile. So 1,700, that would be like rounding to the nearest whole number. So that 5, since the 8 is after it, becomes a 6. And then don't forget to label this with miles. Okay, that's the first example. The second example for this section tells us the height and weight of adults can be modeled by this equation, y equals 47.1x minus 122, where x is the height in feet and y is the weight in pounds. What does the slope of the line represent? So let's start with our slope. Slope is the number in front of x. It's a positive number, so let's explain that it's an increase It's specifically an increase of 47.1 rise, which would be pounds, for each additional x value, which is foot. Part B, what does the y-intercept of this function represent? So remember, our y-intercept is this last number here, which is the negative 122. Let's write that as an ordered pair, so 0, negative 122. And then explaining this, and again, this y-intercept does not make sense in relation to the problem. At 0 feet, since x is our height, a person weighs negative 122 pounds. Doesn't make sense in context, but we do need this correct y-intercept in order to get the correct values when we start substituting in on the next three problems. What would be the weight of someone who is 5.15 feet tall, round to the nearest tenth? So the 5.15 feet, we need to decide, is that an x value or a y value? And since x would be our height in feet, that's an x value. So we're going to substitute in for x into our equation. So we have 47.1 times 5.15, subtract the 122. And then rounding to the nearest tenth, should be getting 120.6 pounds for this person's weight. Part D, what would be the weight of someone who is 7 feet tall, rounding to the nearest tenth? So again, we're substituting in for x, 47.1 times 7, subtracting 122, gives us 207.7 pounds. And then our last question, what height corresponds to a weight of 130 pounds? So this time, instead of giving us an x, they're giving us a y value. So when we substitute into our equation, we want to put in 130 equals 47.1x minus 122. And then solving this equation, we would add 122 to both sides of the equation. And then divide by 47.1. This time would they want us to round to the nearest hundredth. So rounded to the nearest hundredth, we have 5.35, and then make sure we put the correct label of feet for the height of this person.